Section 3, we review addition and subtraction of mixed numbers. So the example is going to be, let's say you had 16 1/8 and you want to add to that 5 5/8 and you want a result. The result in this case would be 21 3/4. There are a number of ways that you can actually do this. You can first convert the mixed numbers into improper fractions and then find the lowest common denominator, and then you should be good to go. I think for the most part, it's likely going to be easier if we just kind of draw a line between the whole numbers and the fractions. If we draw a line between the whole numbers and the fractions, and then solve them almost independently, and then bring them back together at the end, it might make our lives a little easier. So let's take, for example, 16 1/8 and 5 5/8. Let's see how that would work. So if we're asked to add 16 1/8 to 5 5/8, what I'm going to suggest to you is that we actually treat these independent of one another, at least initially. So what I'm going to suggest is we first solve the fraction. We first solve the fraction addition. So let's pretend we don't even see the whole numbers here first. Let's just focus on the fractions. We have 1/8 plus 5/8. So the results would be 6 over 8. The good news is that we have a common denominator here. But even if we didn't have a common denominator, we've already went through that process in the previous section, how to come up with a common denominator. But in this case, we're adding these, so we have 6 over 8, which is going to be reduced then to 3, 4. And we talked about how to reduce these also in the previous section, so you can revert to that if that's confusing to you. So 6/8 is equal to 3 over 4. And then let's add these up independent of the fraction. 16 plus 5 is 21. So we had 21 6/8, but the 6/8 is going to be reduced to 3/4. So the final answer is going to be 21 3/4. There's an example here, example number 2, that shows a rubber gasket must extend around all 4 edges, the perimeter of the dishwasher door panel shown in the following picture before it is installed. So find the length of the gasket material needed by adding 34 1/2 inches, 23 3/4 inches, 34 1/2 inches, and 23 3/4 inches. So the perimeter that circles the dishwasher where the gasket needs to go, if you think of a gasket, it's like just kind of a little rubber, like a little rubber hose, maybe just a piece of rubber. It probably is a little bit thick, but it will go inside to kind of block the water from spilling outside. It'll go between the door and the actual dishwasher. When you close the door, the rubber traps or keeps the water from filtering through the sides. Okay. So what are we going to do? We're going to add these all up. We're going to go vertical on this. We're going to line those up. So we take the numbers that were provided, list them vertically, and then, as I suggested to you earlier, we're going to separate the whole numbers from the fractions. And we know that 2 and 4 and 2 and 4, well, the least common denominator for 2 and 4 is going to be 4. So if it's 4, then 3/4, that 3/4 comes over as 3/4. There's no modification to that. But 1/2 has to be modified. So 2 goes into 4 2 times. Remember the backward z. 2 goes into 4 2 times. 2 times 1 is 2. So the modification of 1/2 so that it now has a denominator of 4 results in 2 over 4, 2/4. And that occurs again here. So 2/4, 3/4 comes right over because the denominator is 4. 2/4 is here, just like we did before, and then 3/4 or 3/4. All right, so we're going to first add up all the fraction. 2 plus 3 is 5. 2 plus 3 is 5 as well, so 5 plus 5 is 10. So 10 over 4. And then we're going to add up the whole numbers, which total to be 114. The result is we have 114 and 10/4. Now 10/4 is an improper fraction. So we need to convert the 10/4 from an improper fraction to a mixed number. So we're going to separate it again. This is what the whole point of keeping those numbers separate is. We're going to take the 10 over 4 and we're going to modify it so that using the previous section that we learned how to take a mixed number, how to take an improper fraction and convert it to a mixed number. The result would be directly 2 2/4, but we also recognize that 2/4 is equivalent to 1 over 2, or 1/2. We're going to take the whole numbers and bring them together now. So 114 plus this other whole number gives us 116. So we really are looking at 116 and 2 over 4, but that 2 over 4 can be reduced further into 1/2. So the final answer to this question is 116 and 1/2 inches. So what you're going to do is you're going to go over to the whatever store you're attending. Did they give us a specific store here? Let's say you're going to go to Lowe's and try to buy a gasket. You have the size of the gasket. You tell the person, the helper who's come to you and asked you what you need, you give them the size of the gasket, and the next question that this helper has is, well, how long does it need to be? Well, because you ran your math, you figured out that what you really need is 116 and 1/2 inches. Subtracting mixed numbers, very similar, except instead of adding, we're subtracting. We still have to have a common denominator, but the example shows here is 8 5/8 minus 3 1/12. Well, 5/8 and 1/12 can be computed separately from the whole numbers. So we're going to convert the 5/8 and the 1/12 to using the lowest common denominator. We previously learned how to come up with that lowest common denominator. In this example here, we're looking at 24. So we plug 24 on both cases as being the lowest common denominator. And then we come up with our adjusted fractions, just like we've learned in previous sections. So now we have 15 over 24 minus 2 over 24. So 15 minus 2 gives us 13. Therefore, the result is 13 over 24. And then we treat the whole numbers independent, separately from the fractions. 8 minus 3 gives us 5. So the result, 5 and 13/24. Now this worked okay because our fraction, our top fraction, was larger than the bottom fraction. But you can have a situation where that's not the case. And when that occurs, we have to figure out a way to solve the problem. Let's take a look at this example here where we're subtracting 6 3/4 from 10 1/8. So to list this out on paper, we have 10. So the problem says subtract 6 3/4 from 10 1/8. Well, that means we're going to start with 10 1/8 and we're going to subtract 6 3/4. So 10 1/8 minus 6 3/4. We're going to treat these as independent. We're going to treat these as independent computations, but first we know that we have to find the lowest common denominator of 8 and 4. Well, that's relatively easy. We have 8. 8 becomes our lowest common denominator. We could use the previous examples, previous sections where we learned how to do this. And now we convert our fraction to the new denominator. Well, this is easy because it's 1/8. There's no change. This one, however, 4 goes into 8 2 times. 2 times 3 is 6. So now it looks like we're ready to go. We're going to take 1/8 and subtract 6/8. But now we have a problem. The problem is 1 minus 6 won't work. We can't use negative numbers here. We're dealing with fractions. So the question is how do we make this work? Well, the book describes it as borrowing, but like I've mentioned before, I don't see much borrowing here. We're going to take the number or we're going to jack it. We need to take a number from 10. We're going to take a whole number from 10, and we're going to use that whole number to make it so that we're going to add that whole number to the 1/8 to make it so that it's larger, and then we can then use it as a way of subtracting the 6/8 from that. So how are we going to do this? We're going to take a number from this. That's going to leave us with 9. So we've jacked a 1. We're left with 9. And we've got a 1 now. And we're going to take this 1 and we're going to add it to 1/8. Well, how do we do that? Well, we look at the denominator of the number we want to add to, and that is 8. So what do we know? What do we know? We know we have 1. Well, 8/8 is equal to 1. So we looked at this denominator and created the number 1 in a fractional form using that denominator, which means we're going to use 8. Well, 8/8 is 1. So now we're going to take 1/8 and add to it 8/8. Well, so 1/8 plus 8/8 will give us 9/8. 1 plus 8 is 9. The denominator carries over. So now we've converted this 1/8. We've added 1 to it, the 1 that we took away from the 10. The 1 is in the representation of an 8/8, and now we have 9/8. So now we have a number we can use to subtract. We can subtract 6/8 from 9/8. That is doable. So just to make it easier to see, we're going to take this number and pull it over here. And now we're going to take 9 and subtract 6. So that's going to leave us with 9 minus 6 is 9 minus 6 will give us 3. And the denominator flows down. So we have 3/8. Okay? So that solves the fractional issue. Now we go to the whole numbers. Well, we've reduced this 10 down to a 9. So now we have to just run the numbers with the new whole numbers we have. 9 minus 6. 9 minus 6 is 3. So our answer to the problem of 10 1/8 minus 6 3/4 is 3 3/8.